Okay, so for 25, it gives you the volume of a cone. R is the radius of our cone, and then V stands for volume. So there's the equation. Then it says the rate of change of the radius with respect to time. So guys, remember, rate of change means derivative. And because it's with respect to time, that means this 6 is our dr over dt. The derivative of the radius with respect to time. It wants us to find the rate of change, so the derivative, of the volume with respect to time. So we're trying to find dV over dt. So we're going to take the volume equation. Because it is the way it's written right now, if you want to multiply it out, then you won't have to use the product rule. But you can use the product rule. But I'm going to multiply it out. So if I multiply out, so this, you're just like multiplying. So this will be 10/3 pi r squared, and then minus 1/3 pi r cubed. So this is the same volume formula, just I multiplied it out. So now I'm ready to find the derivative. Derivative of v would just be 1, but we're doing the derivative with respect to time, so you have to put dv over dt. Alright, derivative of this first little section, if we do 2 times 10/3, that'll be 20/3 pi r. But then you got to write dr over dt beside of that. And then if we found the derivative of this part, 3 times the negative 1/3 will just be -1. So negative pi r squared. And then we're finding the derivative with respect to time, so dr over dt. So we're trying to find dv over dt. And we know dr over dt is 6. So we're going to plug in 6. We do not know what the radius is, so we're just going to leave the radius as r. So we're going to simplify. So 6 divided by 3 will give me a 2. So this is going to be 40 pi r minus 6 pi r squared, which is going to be your rate of change of volume with respect to time. So 40 pi r minus 6 pi r squared.